Right, so in this video we're going to continue looking at simultaneous equations, and we're going to look at a different method for solving simultaneous equations because it's used for some other types that we're going to study in the next video. So I'm going to tell you what the method is. Basically the method is you rearrange one equation to make one of our variables the subject, and then we'll substitute that into the other equation, which then makes it a linear equation which we already know how to solve. And you can find that variable, then you can substitute your solution into one of your two original equations to find the other variable. So let's do a couple of examples just to show you what I mean. I think what I'm going to do here is I'm going to make x the subject. So now I'll be left with x equals 11 minus 4y. And now because this is x, we can replace this x here with 11 minus 4y. And then we've still got y, which equals 1. So this is the second equation I'm substituting into here. So this isn't an original equation, this is a linear equation that I've made by using some substitution. And we're now going to solve that. So then we get 11 minus 5y equals 1. Then we'll subtract the 11 from both sides, and then we get minus 5y equals minus 10. And then when we divide both sides by minus 5, we get y equals 2. We don't need that anymore. That was just to find our y. Now that we know y, we can substitute into either of these equations. And I'm going to choose the second one because it's easier. And that's what we like to do in maths. There we go, simply add this minus 2 to both sides and get x equals 3. So that was very easy, that last bit there. So I'll write out the solutions again next to here. So you can see x equals 3, y equals 2. That's the solution. And the second one here is slightly more difficult with the rearranging part, but we'll just ignore that this is 2y for now, and we'll just move this to the other side and make it minus 3x. But now because this is 2y, what we need to do is we need to divide. We need to divide all of this by 2. So we'll get 7 minus 3 halves of x. And this could get a bit nasty here because we'll have to substitute that here for y, so that we can make this all x's. But this fraction will soon disappear, so that's why I've made this example. So let's say I'll put it up here. So I'm going to have 5x, and I've got minus 2. And then we've got this expression here, because remember this is now y, and then this is equal to 18. Now we're going to simplify this, so we're going to get 5x minus 14. Then when we multiply this here, we can get rid of our fraction, and we've got minus 2 times another minus there, so that's plus 3 x. That's still equal to 18. So let's work this bit out now. So we get 8x minus 14 equals 18. And then we'll add the 14 to both sides. So we get 8x equals, let's see, 36 there. That's actually, no, that's not 36 at all, that's 32, sorry, if I did that to the other side, that's 32. So then we'll divide both sides by 8 here, and we get x is equal to 4. Don't know where 36 come from, but never mind. So x equals 4, and we can substitute that into one of our equations here. Let's substitute it into the first one. You could substitute it into either, but I'm choosing the first one. So then we get 12 here, plus 2y equals 14. And then there's 2y. We subtract that from here. Then we get 2. 2y equals 2, y equals 1. Because we've divided by both sides by 2. So for this one, the solution set x equals 4, y equals 1. Now, because we've studied these simultaneous equations for a bit now, we're going to look at an application. So here's the problem. The sum of two numbers is 36 and the difference is 8. 66, sorry, not 36. I read that because I was still thinking about the 36 from before. So, what we're going to do is we're going to let one of the numbers be A and the other number be B. So the sum of them is 66. So we can write that algebraically as like that. That's a B. That's how we write it algebraically. And then I've got A minus B equals 8. And what we'll have to do is we'll have to find the A and the B. We'll have to find what two numbers sum to make 66 and have a difference of 8. So we could use this method, or we could use the method from the other one. I'm going to use this method. And basically what I'm going to do is I'm going to say A equals 8 plus B, and then what I can do now is I can substitute I should put me 8 plus B for this part. So I've got 8 plus B equals 66, and then I've got 8 plus 2B equals 66. Add 8 to both sides. we'll get 74 divided by 2, b equals 37. Then if I substitute that into my other equation, that's b, so I can basically just do 66 minus 37, which is pretty easy. So it is 29. And that's the solution.